This is 2023 paper 2 A-level maths. Okay, so we've got this quadratic here. We've got roots at 2 and 5, and we just want to look for the values of x that make the quadratic greater than 0. So we just want to be above the x-axis, basically. So we want to be either less than 2 or greater than 5. And you want to be or, it's not and. This is intersect, means and. This is or, so we want to be this one. It's given that this and this equal that. Find the value of this. So if we just draw the function f of x, say it looks something like this. It won't actually look something like this because between 3 and 6, it should actually be lower than, it should be below the x-axis because it needs to be negative, but it's fine, it's just a sketch. Okay, so between 3 and 6, right, we know that the value here is going to be minus 10. Right, we'll just say it's minus 10 because that's what the question told us. But we know that between 0 and 6, the value is 20. So if you want to be between 0 and 3, you want to do this full area between 0 and 6, so you want to do 20. Take away this area here, which is minus 10. So 20 take away minus 10, which is 30. Circle is this equation. This 16 is r squared, so the radius would just be square root 4. Find an expression for dy by dx. Just write it in the normal form. Multiply by the power, reduce the power by 1. You'll get this. This is a quarter, and that's your answer. Point P with coordinates. This lies on the curve. Okay, well, we've got the gradient function, which is cis. So then when we plug in x equals 4, we'll just get the gradient at that point, which is 2. So we've got y minus y1 equals m times x minus x1. So y minus 10 equals 2 lots of x minus 4, and that's your answer. Show that the curve has no stationary points. If it does have a stationary point, then that means dy by dx would equal 0. I'm just going to write this as 2 over x to the power of a half, or 2 over square root x. I'm going to multiply by x to the power of a half on both sides. X times by x to the half is x to the power of 1 times by x to the power of half. You add the powers, so 1 plus 0.5 is 1.5, so 3 over 2. So you've got a quarter x to the power of 3 over 2 plus 2 equals 0. I've multiplied by 4 on both sides. I've brought the 8 to the other side. I'm going to cube root both sides. Okay, so both sides to the power of a third. To get x to the power of a half equals minus 2, or square root x equals minus 2. Now you can't just square root this because you have to realize that you can't square root a number to get a negative, right? Just imagine putting a value. If you square root both sides, you'd get x equals 4. But if you plug in x equals 4 back into this, you wouldn't get minus 2. So there are no solutions, so therefore no stationary points. We've got this person here is a long distance swimmer. A length of the pool is 25 meters. On the first day he swims 10 lengths, and each day after that he increases the number of lengths by 4. So he'll swim 10 lengths for the first day, and then for each day after that he's going to swim 4 extra. So he's going to add 4 each n time, but it's actually n minus 1, because on the first day when n equals 1, this here will go away to 0, so that he only swims 10 lengths. So then on his second day, he'd actually be swimming 2 minus 1, so he'd be increasing it by 4. Okay, hopefully that makes sense. If you just simplify that, you get 4n plus 6. Just be careful. It says expression, not equation, so don't make it equal to anything. He wants to be able to swim at least 3,000 meters in one day. Each length we know is 25 meters, and so it's going to be 120 lengths per day, because if he wants to do 3,000 meters in one day, and each length is 25 meters, then if you do 3,000 divided by 25, you'll get 120 lengths per day. And 4n plus 6 is the number of lengths, so we just want this to be equal to 120. We just want to say, well, what value of n, i.e. what day, would get us 120 lengths per day. Okay, so you set that equal to that. You get n is 28.5 days. You can't have half a day. It says the minimum number of days, so that's 29. The coach is saying that by the time 29 days has passed, he'll have swam over 50,000 meters. Let's just check if he's right. So 29 days of swimming is... I'm going to do it wrong the first way, and then I'm going to explain why it's wrong, and because this is what I feel like lots of people would do when they're first answering this question. So I'm guessing lots of people would say 29 days of swimming, 3,000 meters per day, that's 87,000 meters. But this is wrong, because the value that the amount of meters he swims each day isn't constant. It's going to increase each time, because each day he increases it by 4 lengths. as it says here. So if you just imagine, well, on the first day he's going to swim 10 lengths. 10 lengths is 20 times 25 to get the number of meters. That's 250 meters. And then day 2 he's going to increase the lengths by 4, so that's going to be 14 lengths. 14 times 25 is 350 meters. And if you carry on this, you'll get this. So it's a arithmetic sequence, and you increase this by this each time, which we already kind of knew because we got 4n plus 6, and then we just have to multiply that by 25 to generate the sequence. And then we want to sum up this arithmetic sequence up to the 29th day. Okay, so the first term is 250. We want 29 terms, and the common difference is 100. Okay, so just plug it into the formula. It's in your formula booklet. You'll get 47,850 meters total. This is less than 50,000, so the coach is wrong. I've just shown it here the other way. This is 4n plus 6, which we got last time. So if you convert that into meters by times in by 25, and then generate the sequence, and then do it that way, it's both the exact same. You get the same answer. Okay, next question. So we want to find the value of a here, and we've got this equation. Usually when you see questions to do with logarithmic graphs, they want you to put in, some value of 0 in there just to see what you get out. We've got this v equals a b to the power of n. If we plug in n equals 0, i.e. the y-intercept of this graph here, we'll get v equals a. Okay, so when n equals 0, we've got v equals a. Now here we can see that a is the y-intercept, but the y-intercept is just 1.76 as we're reading from here. So log base 10 of v equals 1.76. So if we take 10 to the power of both sides, then we get v equals 57.74, which is a, and that's approximately equal to 57.5. Find the value of b, give you answer to 3 significant figures. We've gotten this equation, and we've also got this one. I'm going to take log base 10 of both sides of this equation here. I'm going to separate this out because you're multiplying two things inside the log. This is just a constant, but look at this. The gradient here is going to be 0.057, and the gradient here is going to be log base 10 of b. Now both of these equations are exactly the same because this gives you 1.76 as we saw earlier. So log base 10 of b must just equal 0.057. 10 to the power of both sides gets you b as 1.14. State the Euler percentage increase. Well, if we've got this equation here, just look at it. It's kind of like the compound interest one. And if we're constantly multiplying by 1.14 after n years, then it's just a 14% increase. It's 1 plus 14%. It's 100% plus another 14%. So that's 14% increase. Predict the average weekly rate of online groceries in 2025. It started in 2009 here, so that's 16 years later. So n equals 16. You plug that in, you get 467.9. But just be careful. V is in millions of pounds here, so just put million pounds. Explain why the prediction may be unreliable. There's tons of things that you can say, but I just said that the increase is not likely to be constant. Also, I'm not sure. There was some missing spaces in here. I don't know if the question didn't ask to fill these in. I might have missed it. I'm sure you know how to do it if it did ask and I just missed it. We've got a function h of x equals g f of x. This is kind of like saying g brackets f of x close bracket. So I replace the input of g of x. So replace the x with whatever f of x is. So we're just trying to plug f of x in for the x inside g of x. This is just GCSE stuff. You just plug this into there. That's it. Find the domain of h. Well, if you look at this, we want this to be greater than 0. Careful, it's not equal to 0 because you can't divide by 0. So we just want 10 minus 2x to be greater than 0, so i.e. x is less than 5. Show that the inverse of h is this. The proper way to do this is you say h of x equals that, and you say let the inverse equal y. Okay, and you apply the function h to both sides to say x equals h of y, and h of y is just when you replace everything inside of h of x with a y. So i.e. x equals 1 over square root 10 minus 2y. You might prefer to just swap the x's and y's as you might have been taught. Anyways, then we're just going to go ahead and rearrange for y. You multiply by 10 minus 2y on both sides, divide by x squared on both sides to get this. Add 2y to both sides, divide by 2 to get that. Y equals the inverse of h, so that's that. Given that cosine theta is not equal to plus or minus 1, prove this. Okay, I'm just going to combine them. So left hand side equals just that. I'm going to combine this. I'm going to multiply by 1 plus cosine theta. over 1 plus cosine theta, and then multiply this by 1 minus cosine theta over 1 minus cosine theta. Add these together, the cosine theta's cancelled. We've got 2 over this here. I'm just going to multiply this out. The cosine theta will cancel and you'll get minus cos squared. So you'll get 1 minus cos squared theta. 1 minus cos squared theta is just sine squared theta. 1 over sine squared theta is just cosec squared theta, which is just 2 cosec squared theta here, which equals the right hand side. Find the set of values of A for which the equation has real solutions. Okay, so we know that this here equals 2 cosec squared theta. And so if we divide by 2 on both sides, we'll get cosec squared theta equals A over 2. Now let's just consider the graph of cosec theta. Cosec theta, it'll have like these, it'll have like this, it'll have like a curve down here as well. But I've just gone ahead and I've erased it out because if you have cosec squared theta, all of the negatives are going to reflect up to become positives. Okay, so you'll actually have them up here as well. Okay, but just think about what this is actually saying. Okay, it's saying for what values, it's saying we've got the graph y equals cosec squared theta, which is what I've kind of done here, just minus this part, which I should have really included, but it's just difficult to draw it in PowerPoint. Okay, but the idea is there's nothing down here below the x-axis. Anyway, so what value, it's saying when does y equals cosec squared theta intersect the line y equals a over 2? Now, the line y equals a over 2, that's just going to be a horizontal line. If you drew the line in here, you wouldn't have any real solutions because there'd be no intersections. But if you drew it here, we're getting closer to where there'd be solutions, but there isn't actually any. But if we drew it here, so just on this line here, right, that's when we're getting at least one solution. Okay, so we can notice that as long as we're on this line or above, then there are going to be real solutions. Here is also perfectly fine. But if we're here or above, then we do have real solutions. Now, cosec squared theta, this value here is just going to be 1. For cosec theta, it's going to be 1, and then you're going to square it to get 1 squared, which is still 1. So cosec squared theta is always greater than or equal to 1. So this y value here is 1. So we just want a over 2 to be greater than or equal to 1, i.e. we want a to be greater than or equal to 2, which is the answer. Given that theta is obtuse, this equals 16. This is 2 cosec squared theta as we've seen. Divide by 2 on both sides, you get this. Let's look at this Pythagorean identity, right? If you go ahead and divide by sine squared on both sides, we'll get 1 over sine squared, which is cosec squared, which is what we wanted. That's why I did that. And then you'll get cos squared over sine squared. Now, sine over cos is going to be tangent. That means that cosine over sine must be cotangent. And then if you just square that result, you'll get cot squared x. So cot squared x plus 1 equals cosec squared x. So replace this cosec squared theta with cot squared theta plus 1 equals a, and then you rearrange, you'll get this. You can have a positive solution or a minus solution, but just be careful. Let's just consider the graph of tangent, right? If you do the reciprocal of tangent, then the domain isn't like... If you imagine it like this, right? If theta is obtuse, right, you're going to want to be between 90 degrees and 180 degrees. You don't want to be greater than 180 because then you'd be reflex. So we want to be between pi over 2 and pi. So between here and here, or between here and here. Now you notice that at these points, tangent is negative, right? But it also means that cotangent would also be negative, because if you just do 1 over a negative, you're still going to get a negative. So cotangent is negative whenever theta is obtuse, i.e. between pi over 2 and pi. So of these two solutions, we actually only want this one, and we can discard this positive solution. First 3 times of this, we've got this formula here. This is, by this 1.2, it means like 1 times by 2. It's just not very good, like, they've just not written it very well. Anyways, you just plug it in, just plug in n equals minus a half. Yeah, 1 minus half x plus minus a half times by minus a half minus 1 over 1 times by 2, which is just 2, multiplied by x squared. You just rearrange that, sorry, you just simplify that, you'll get that. So student substitutes x equals 2 to find an approximation for 1 over root 3. What's the mistake? Well, let's just look back at this. In the formula booklet, it tells you that the absolute value of x needs to be less than 1. But if they're plugging in x equals 2, that's not less than 1. It's greater than 1. So, you know, because this is only valid for the absolute value of x is less than 1, then you can actually substitute x equals 2 into it, because it doesn't I don't think it converges. I think that's the correct terminology. By substituting x equals minus a quarter in for this expansion, find an approximation for 1 over root 3. Okay, this is the expansion that we got. We only did the first 3 terms because it's an approximation. If we plug in x equals minus a quarter into this, we'll get this to the minus a half. And then we'll plug in x equals minus a quarter into this. We'll simplify this side here. We get 1.14844. And then we'll also simplify this side. We're going to take the reciprocal because it's a negative power, and then square root it because it's to the power of a half. So we get 2 over root 3 equals this, but we want 1 over root 3, so we'll just divide by 2 on both sides, and we'll get that to 3 significant figures. Expand this, a squared minus 2ab plus b squared. Peter thinks that the sum of any irrational numbers and its reciprocal is always greater than 2. Okay, so he's saying that a number plus its reciprocal is always greater than 2. So let's just find a case where it's less than or equal to 2. If you can't actually think of one, then you can just solve this carefully. If you're going to solve it, multiply by x squared on both sides. Because if x was negative, then this inequality would swap. Or just solve it any other way that actually works. Anyways, you might just be able to see that, oh, well, if we tried any negative number, then you're going to get a minus number plus a minus number, which will always be less than 2. Okay, so less than or equal to 2, so you'll just get minus 10.1 for this example here. Given that a and b are distinct positive integers, use proof by contradiction to prove that this. Okay, just if you're ever doing a proof by contradiction and you're not sure what to assume is actually false, the idea is don't assume what is false, what they've actually given you as true fact, right? So the true fact that they've given us is that a and b are distinct positive numbers. We can't change that. We just have to accept that. Okay, it's not something we can assume is wrong. What we can assume wrong is this inequality, right? It could actually be less than or equal to 2, so let's just assume that's the case. So we've got this is less than or equal to 2. I'm going to multiply by a on both sides, multiply by b on both sides to get a squared plus b squared is less than or equal to 2ab. Take away 2ab from both sides. This factorizes perfectly into a minus b all squared is less than or equal to 0. But let's just be careful, right? The only case in which this can ever equal 0 is when a equals b, right? Because then you'd have something take away itself, 0 squared equals 0. Okay, that's the only case where this could actually be possible. It can't be less than 0, we know that for a fact, because when you square a number, you're always going to get a positive. But look, a and b are distinct, which means that they're not going to be each other, right? Therefore, this first of all just can't be equal to 0, so, you know, it must be less than 0. But this is a contradiction, because any number squared is going to be greater than or equal to 0, right? So this must be false, meaning that this is true, so that these are greater than 2. You might want to just write it out properly instead of saying this. We're on to the mechanics part now. Decoration has a mass of 0.2 kilograms, light and extensible wire. We're told about its length. The length doesn't actually affect the tension in the wire. If you just think about F equals ma, there's nothing there to do with length. It's just the mass of it, 0.2 times by 0 times by the acceleration due to gravity, because it's just hanging. So that would be 9.8 or 0.2 g newtons. We've got a particle. For the first 4 seconds, its displacement is 0 meters. Okay, well, if its displacement is 0 meters and we've been given velocity time graphs, then imagine if you integrate velocity, you'll get displacement, which just means that if you have a velocity time graph, because we're integrating with respect to time, then a velocity time graph, anything which is the area underneath it, is just going to be a displacement. So we just want the area underneath each of, we want to find the area underneath each of these graphs, and we want that to equal 0. Anything below the x-axis will be negative, because we need it to be negative to cancel the top to actually get 0. Unless it was just a straight line through 0. But anyways, it can't be this one, right? Because there's nothing below the x-axis to actually cancel away from this area. So this area is definitely greater than 0. With this one here, well, actually, I'll leave that one till later. We know it's definitely not going to be this one for that same reason. So it can either only be this one or this one. Now, I kind of just like, I did this in a really wishy-washy way because I didn't want to actually compute the areas. So I just thought to myself, well, this one looks much smaller than this one. At most, I feel like this could only cancel with this from what I'm seeing. Well, it looks like it does because of the symmetry. 2 this way, 2 that way, same height. So we've still got this area that's not cancelled out, which means that this area here is probably the same as this area. If you computed it, you would get that they're equal. So this is our answer, because this positive area would cancel with this negative area to get 0. This one wouldn't give us 0, neither would this or this. Ball falls freely towards Earth. It goes through 2 points M and N. At M it has u meters per second velocity, and at N it has 3 meters per second velocity. The only force acting on it is the gravitational force, and the acceleration is constant, which tells us that we need to use suvat. We want to show that the time taken for the ball to reach travel from M to N is 2u over g seconds. The displacement we don't know. We'll just write down suvat down the side. Okay, we know that the initial velocity is obviously u at M, and then the final velocity must be just 3u. Its acceleration is just that due to gravity, so g. Okay, and that's all we need, right? We only ever need 3 values in suvat to work out something else. Okay, if we use this equation here, v equals u plus at, u is u, v is 3u, a is g. We'll get this, just rearrange, get t equals 2u over g, which is what we wanted. Point M is h meters above the earth. Show that h is greater than 4u squared over g. I've just written suvat down again. Okay, if you imagine, if I just draw a really simple diagram here, let's just say that this is the point M, this is the point N, and this is h, the length h. Okay, if I go ahead and, if you look at this, right, it wants us to do something, we're comparing heights basically, right? If we're comparing heights, it's a really big indicator that we're looking for displacement. So let's just find what the displacement would be. Okay, so let's use this suvat equation. All of the suvat equations are given in the formula booklet. V is 3u, you'll get this. This becomes 9u squared equals u squared plus 2gs. If you rearrange for s, you'll get 8u squared over 2g, which is just 4u squared over g. Okay, so we're looking like we're getting really close to the answer, but how do we actually include this h? Well, this is the point M and N, as I said earlier, and this distance here that it travels, this displacement, should I say, sorry, is 4u squared over g. Okay, well, there's a really important, like, the easiest way to include h as part of an inequality is to say, well, the total distance travelled, which would be from M to N and then N to the floor, is just going to be 4u squared over g plus h, right? But we know that the total distance travelled must be greater than 0. Okay, it can't be 0. I'll just put that on the side. It can't be 0, because if it was, then, you know, you're not even dropping the ball, you're dropping it from the surface. Okay, because it's traveling 0 meters. But we know that can't be true because we are actually dropping the ball. It's got some velocities to it. Okay, so if we subtract h from both sides, we'll get this. Okay, but it's not facing the correct way, and we've got a negative sign, which means, so what we can do is multiply by -1 on both sides. Okay, and then if you do that, the inequality will flip. Now, if you did that, you would get a -4u squared over g is less than h, which is what we want to get, but we'd have a minus in ours. But the thing is, I think what you can do, I think you can just explain here that because it's a distance, okay, well, a displacement, should I say, then we can just take it as a positive. So even though we know it's going to be a negative from manipulating it, we can just take it as a positive because it's still just a distance that we're traveling. Okay, so I think I've justified it enough to be able to, you know, justified it in my own words to say that this is correct. A car has an initial velocity of 1 meters per second and is moving in a straight line. The acceleration a meters per second squared of the car at time t is given by this. Well, actually, something to just say, if you wanted to justify that just a bit more clearly, in words, what you could say is, because we've basically assumed that downwards is positive by saying that we've got positive u, positive 3u, positive g. So if going downwards is positive, but we take this height h from the ground up by h, we're kind of going the other way. So this h would actually be a minus h. So we'd actually have 4u squared over g minus h is greater than 0. And then if you brought it to the other side, and then you'd bring it to the other side to say 4u squared over g is just greater than h, and then if you multiply by -1, and then went from there to say that because they're displacements, we'll just take them both as positive, and then you'd get maybe a more justified answer, but either way, it's all the same. Anyways, let's get back to this. This is non-uniform acceleration because it's modeled by some function, some polynomial. Basically, we're told that the velocity is 10 when t equals 3, and that it initially begins at 1 meters per second. We want to show that k equals 1/3. If we integrate acceleration with respect to time, we'll get velocity. So all we need to do is integrate this. This becomes 3kt to the power of 3 over 3. This becomes minus 2kt squared over 2, and then this becomes plus k plus some constant c, and that equals velocity. Okay, now when t equals 0, v should equal 1 because that's just the initial velocity. So that means c equals 1. We'll plug that back in, we'll get this. You might have just been able to go from this line to this line here without actually plugging anything in. Anyways, you'll get this. We know that when t equals 3, v equals 10. Plug that in, you'll get k equals a third. We've got a particle. It's a rough horizontal surface. Q has a weight of 0.65 newtons. Just be careful here. This says weight, not mass. So it's not 0.65 g. It's just 0.65 newtons. Let's just draw out. We've got a coefficient of friction. We've got acceleration of this. 0.65 newtons acting down. So we have a normal reaction force of 0.65. We have a driving force of d, and we have a resistive force of mu r. But mu times the mu times the normal reaction force. Mu is 0.4, the normal reaction force is 0.65. You'll get this, and the acceleration is 0.91. Now let's just think about this, right? What we're going to do is we're going to do F equals ma on this entire system here. Okay, but we're going to need the mass for it. Okay, now if we say F equals ma, but the acceleration is g, i.e. just this downwards force here. Okay, then the weight, the force which, because weight is just a force, the force which is the weight, 0.65 equals m times by acceleration 9.8, and then if we rearrange for m, we'll get this as the mass of this particle here. Okay, you might have just been able to see that all you need to do is divide by 9.8. It's all the same. Anyways, we'll resolve forces now. So we've got d minus 0.4 times 0.65 equals the mass, this times by the acceleration, this. Rearrange for d, you'll get that. A particle moves under the action of two forces. The acceleration of the particle is this. The net force is just going to be the sum of all the forces acting on the particle. So we'll just add this up. I've just put it here in terms of I and j. I'm going to write them out as vectors like this. And this force equals the mass times by the acceleration, which is this. Okay, so now we can just look at the top. We've got 1.6 plus k equals 3.2m, and we've got minus 5 plus 5k equals 12m. Just solve these simultaneously. You can do that. You'll get k is 8.8. Here we've got moments. We want to show that the mass of the Planck is 9.6. It's uniform. It says somewhere. Yep, uniform Planck, which means that the weight is going to act at the center. Okay, so it's going to act 3.5 meters across from P or from Q. Either way is fine. Anyways, we've got a normal reaction force 4g here, and then we've got the weight acting down here, which is just mg. Now what you could do is you could take moments at somewhere else, but the issue is you'd have to work out what the moment at y is. Now just a tip, if you don't know what the moment is at a particular point, then just take moments from that point, because the distance from that point to that point would just be 0 meters. So the moment would be 0. So if we take moments at y, we don't actually need to calculate the moment at y. Anyway, so if we take moments from y, we need to go across this distance here. This distance is easy to work out. We know that this distance here is 3.5. So 3.5 take away 2 is going to be 1.5. So we've got 1.5 mg moment acting this way, counterclockwise. And then we've got clockwise moments of this distance here between y and x. That's going to be 7 take away 1.4 take away 2 to get this. That gets you 3.6, and then times by the force 4g. So we've got 3.6 times 4g, subtract 1.5 mg equals 0. If we do that, you just plug in 9.8 for g, you'll get m is 9.6. You might just say that the clockwise moments equals the counterclockwise moments, you'd get the same answer. Also, this is negative because it's just acting in the other way. Find the reaction force in terms of g on the other Planck y. Okay, so y is here. There's a few ways that you can do it. Now, the easiest way to do it, which is not the way that I did it for some reason, is you just put a force, the normal reaction force, upwards here, and you'll say 4g plus r equals 9.6 because it's at rest. It's in equilibrium here. So all the forces on it must equal 0. Or you can just take moments at x like I did, which isn't the best way. I wouldn't recommend it. It's just longer. You get the same answer either way. You just do the force times by the distance. And then take moments at both here and here, and you'd get the same answer. Just be careful, if this is down, then this one here would be up, so then you'd get positive and negative, so minus here, positive here. Yep, so this here would be 2.1 times by 9.6, but down I've said is going to be negative, so that's going to be a minus, and then 3.6 times by F, some force, which is going to be positive. G is 9.8, obviously. You get F is 54.9. We want it in terms of G, I think it says somewhere. Does it say that? Oh yeah, here, in terms of G. So just divide by 9.8 and then put the G back in, which is the same. So we've divided by 9.8 only to put the 9.8 back in. Support Y, the support Y is moved 1.4 meters. So basically, it's not going to be in the same place anymore. It's actually moved so that it's only 1.4 meters from Q. So it's going to be the same distance from P to X as Q to the new Y, which means that the normal reaction force is going to be the same at X as it is on Y. Because all the normal reaction force depends on is the force times with the distance, and the force acting down, and then you reverse it to just find whatever the force is acting up. So this person saying that it's going to remain unchanged, but that's incorrect because it depends on the distance from the center to the point Y. If you just imagine like opening a door handle, maybe it's going to be much easier on like the far edge of the door compared to just near where the hinge is. So this person is wrong. So Y's reaction would become 4G, the same as X. We've got some vectors here. We've got a triangle ABC, and find the speed of t as it moves from A to B. Well, this is the velocity vector, so the velocity is just going to be the speed is just going to be the magnitude of the velocity vector. So square root of 3 squared plus root 3 all squared. You'll get this, which is 2 root 3. From B to C, velocity vector is this. On this journey from A to B, the velocity vector... Oh, okay, never mind. Yeah, that's the same thing. Show that the angle ABC is 60 degrees. Now, you can calculate the velocity here is going to be 2 root 3, and then the same one here is 2 root 3. But the velocity vector from A to C, if you imagine, it's just going to be A plus B, sorry, A to B plus B to C. So it's just going to be this plus this. Okay, which when you do that, you'll get 2 root 3. So that's just going to be the magnitude of the velocity. Apologies for that, I just had to go back and change something because I realised the way that I'd done it was actually wrong. I made a small mistake. Anyways, I fixed it now. This is the actual way. So if you just imagine, if you just draw this in like these lines in here, you can tell that AB, the velocity, well, we're going 3 across root 3 up, so it's going to be 3 root 3 here, and then 3 across root 3 up. So we'll just put those values in. Now we can find out the angles here because say if we're looking for this angle here, it's just going to be inverse tangent of opposite over adjacent. So tan to the minus 1 of square root 3 over 3, which is 30 degrees. This is 90 degrees, so 90 plus 30 is 120. 180 minus 120 is 60 degrees, which is here. We'll do a similar thing for this here, so opposite over adjacent, inverse tan that. Get 30 degrees here, this is 90. 90 plus 30 is 120. 120 take away 180 take away 120 is 60 degrees. And then angle ABC is just going to be this plus this, and then 180 minus that, because they lie on a straight line. So 180 minus 60, which is 60 degrees. We've got B, and careful here, it's not velocity vector, it's a position vector. So it's got a position vector 1, 0. Okay, and I'm just going to put this equation on the side here. I'll leave that for a second. Now, the fixed origin is just going to be somewhere here. we're not going up or down, so it's definitely along this like line here. It's definitely horizontal through B, and we're just going one to the left to get from B back to the origin. Okay, and I'm just going to put some values in here. So if you remember, the velocity vector from B to C was minus 3 and then root 3. Okay, now let's just think about this way. The question says it's an equilateral triangle, and in total, visiting all of going through all the vectors, it's going to take 9 seconds. But if it's an equilateral triangle, then they must just spend the same amount of time in each vector, because they're given the same magnitude of velocity. So the magnitude of velocity here is the same as the magnitude of velocity here, which is the same as the magnitude of velocity here, which must mean that each one takes 1/3 of the total time. So we're going to spend 3 seconds here, 3 seconds here, 3 seconds here, basically. Which means that from B to C, we're going to travel for 3 seconds. Okay, and let's just say the position vector here is B, and oh wait, I didn't even actually use that. That was for a different method I was going to show, but I just left it because I felt I was doing too much. Anyways, from O to C, okay, we're going to need to go the position vector. We're going to need to go from O to B and then B to C. Now the position vector from B to C, well, we're saying that we know that velocity equals speed over time, so displacement. Velocity equals displacement over time, so displacement equals velocity times time. We know that the velocity is just this, okay, and we know that the time is going to be 3 seconds, as I've justified earlier. So minus 3 root 3 times by 3 is just the displacement from B to C, okay? So we're going to go from O to B and then B to C, and that gets us from O to C, basically, okay? So we're going to B, which is this, and then we're doing velocity, which is this, times by the time this, to get this displacement here. And that gets us OC, which is that. We've got a train here. I'm just going to draw in like tensions and everything, all the resistive forces. You can read through that if you want. We've got resistive force this, so we've got weight this, and we've got acceleration of 0.06, mass of 0.7 here. And is that everything else? Tensions here and here in that small rod. Now, we're going to resolve the forces because we're looking for the resistive force. Okay, and it's better to look at the entire system, because that way the tensions would cancel and we wouldn't have to solve for them just yet. So let's look at let's just resolve horizontally. Now horizontally, if we've got 2 newtons this way, right? I've just put 2 newtons this way as well, just because it's going to be equal and opposite, because it's a rod and the tensions are going to be equal and opposite. Anyway, so if we've got 2 newtons here and we've got an angle of 40 degrees to the horizontal, then this here acting to the right is just going to be 2 cosine 40 degrees. If you want, you should have been shown this, but this here would be the hypotenuse times by cosine of the angle, and then this here would be the hypotenuse times by sine of the angle. You can just let this equal A, this equal B, and then rearrange for A, if you prefer, if you use SOHCAHTOA. Anyways, so you'll get this as 2 cosine 40 degrees. So we've got 2 cosine 40 degrees acting to the right, take away 0.8, take away R, and that equals the mass, so the total mass, 0.7 plus 1.5, which is 2.2, times by the acceleration, 0.06. Just rearrange, you'll get R as approximately 0.6 newtons, which is what we wanted anyways. At the instant that the toy reaches a speed of 0.5 meters per second, the string breaks, and we've got the masses here. I've just copy and pasted it. That's the diagram we had. Now, the string broke, okay, so that means we can just look at each trailer and each engine just separately. Okay, so here we've got T, take away 0.6, equals the mass of the trailer, so 0.7, times by the acceleration, which is A. And then for this one here, there's not going to be a driving force anymore because it's gone, because it says that it stopped it, it's decelerating now. We can ignore this as well. So the forces that we have acting on the engine now is just minus 0.8, which doesn't change, and then minus the tension here. Okay, so minus 0.8 minus T equals the mass 1.5 times by the acceleration A. Solve these simultaneously, you get A as that, and you'll get T is 0.15 newtons, which is what we wanted. Find h. I can't even remember what h was. It's the distance traveled for them to come to rest. Okay, now we know that the initial speed is going to be 0.5, and then the final velocity is going to be 0 because it comes to rest. It accelerates at minus 0.64, i.e., or decelerates at 0.64 meters per second squared. We can just use that. It says that the deceleration is constant. We're using this equation here because we've got UVA. You just plug in the values. It's really simple. It's not actually much difficult maths. If you rearrange, you'll get S is 0.2 meters. 0.20 should I say, because this comes out as like 0.19 something. State one model assumption. There's tons of things you can say. I just said that the rod is uniform. Just read about what the question was actually saying back here, and just try and pick out any mistakes or any issues with it. We're finding the acceleration here. Basically, I'm not going to read through all of this, but we've got this woman. She's throwing this ball here, and it's from a height of 1.8 meters to a height of 0.3 meters. The dog runs 0.2 seconds after she's thrown the ball, and that 0.2 seconds after she's ran, it catches the ball 0.3 meters off the ground. Okay, she throws it initially with 14 meters per second, 60 degrees to the horizontal, and I think that's all the information. Yeah, and using G is 9.8. Okay, so the first thing we want to do is we just want to find how long it's actually taken for the ball to get from here to here. Okay, I'm just going to resolve vertically. Now vertically, okay, we're going from 1.8 meters to 0.3, so we're actually going down by 1.5 meters. Okay, that's 1.8 take away 0.3. So that displacement is going to be minus 1.5. Careful, it's a minus because we've already said upwards is positive because that's what the questions showed us with this positive 14. Okay, so this S is going to be minus 1.5. And we've got an initial velocity of 14 sine 60 degrees. Okay, that's just this one here. So you just use SOHCAHTOA like we did earlier. U is 14 sine 60, acting upwards. And the acceleration due to gravity is the only acceleration acting on the ball vertically. And that's just going to be 9.8. But careful, it's going to be minus 9.8 because it's dragging the ball down, and we said that downwards was negative. So that's minus 9.8. Use S equals ut plus half at squared to get t. If we do that, we'll get t is 2.59 seconds. There was another solution which was negative, but I've just said here that the time needs to be greater than 0. Okay, it shouldn't really be 0. It should just be greater than 0. But if the dog's running 0.2 seconds after that, then the dog's just run out of 0.2 seconds of time which it could have used. So it only actually has 2.39 seconds to catch the ball. Okay, so the dog has 2.39 seconds to catch it. Okay, now, okay, well, we're getting closer to the answer. I can tell we're getting closer. But one thing that would be useful for us to know is how far does the dog actually run? How far away is it? Because if it has 2.39 seconds, we're gonna need it to travel like an appropriate distance of time. It's not going to be like 1,000 meters. It's not going to dash that quickly. So let's just find what the distance is. Okay, so let's resolve horizontally. To find how much the dog has to travel horizontally, we just need to find how much the ball has actually traveled horizontally. Now, t is the only thing which you can copy across from vertical to horizontal when you're doing suvat. So t is the same as 2.59 seconds. Careful, it's not 2.39 because we're looking at the motion of the ball right now, not the motion of the dog. So t is 2.59. Okay, acceleration is 0 because horizontally you don't have any acceleration, and u is going to be this component here, so 14 cosine 60 degrees, or pi over 3. S equals ut plus half at squared again. You just get s, you'll get 18.13 meters. Okay, so this distance here is actually not this distance, it's actually this distance here to here. I drew that in wrong, sorry about that. But from here to here is going to be 18.13 meters. Okay, and the dog needs to travel 18.13 meters in 2.39 seconds. So the time for the dog is 2.39. Displacement is that. Its initial velocity is 0 because it starts from rest. And let's just do suvat again. This is s equals ut plus half at squared again to get what a is. You rearrange for a, you get 6.3 meters per second. This should say 2 not meters per second, because that's wrong. That would be velocity. This should say meters per second squared. Anyways, that's the entire paper. Thank you for watching.